Hello everyone. In this video, I am going to explain about the introduction to sequences. First, what is a sequence? A sequence is a pattern and it can be a pattern of objects, music, letters or numbers. Sequences represent ordered list of elements. Here is a sequence of objects. Rose, sunflower, lotus. Definitely, the next flower in this sequence is a rose. Next example, a sequence of symbols are given. Then, the next symbol in this sequence is ampersand symbol. Third example gives a sequence of numbers from 5, 7, 9 to 23. Then, clearly, the next number in this sequence is 25. Let's move on to the definition of sequence in a mathematical way. A sequence is defined as a function from a subset of n to a set S. We use the notation an to denote the image of the integer n. We call an nth term of the sequence. We use the notation an as within the curly bracket or square bracket or open bracket to describe a sequence. For example, subset of n starts from 1, 2, 3, etc. and the given set as 2, 4, 6, 8, 10, etc. This sequence can be specified as an, where an is equal to 2n, since the set contains set of all even numbers. Another way to represent a sequence is a list of numbers in a given order a1, a2, a3, etc. up to an, etc. Here a1 is the first term of the sequence, a2 is the second term of the sequence, an is the nth term of the sequence. Here n is the index value. For example, in example 1, 1 by 2, 1 by 3, 1 by 4, etc. Here 1 is the first term of the sequence, 1 by 2 is the second term of the sequence, 1 by 3 is the third term of the sequence. In general, nth term is represented by 1 by n. Next example gives the nth term as n by n plus 1, where first term is 1 by 2, second term is 2 by 3, third term is 3 by 4, and so on. Third example gives the sequence as 2 by 3, 3 by 9, 4 by 27, 5 by 81, etc. Here nth term is taken as n by 3 power n minus 1. We note that sequences need not have well-defined pattern. For example, the sequence of primes 2, 3, 5, 7, etc. There is no known formula for the nth prime number. So, this sequence has only a verbal description. Next, we categorized sequence as infinite sequence and finite sequence. What is the infinite sequence? A sequence that goes on forever, and a sequence that has an end is said to be finite sequence. Here is an example for infinite sequence is 14, 28, 42, 56, 70, etc. And the finite sequence example gives the terms 1, 3, 9, 27 and 81. There are two types of sequences with geometric common ratio and arithmetic common difference. Here is an example for sequence with geometric common ratio and arithmetic common difference. In the geometric common ratio idea in the given sequence 2, 4, 8, 16, 32, 64 is, here the terms are 4, 8, 16, 32, 64. So first term is 2 and second term is 4 and third term is 8 and so on. So nth term is taken as 2 power n. And the another example for arithmetic common difference, there are two types of sequences with a geometric common ratio and arithmetic common difference. In the example 2, 4, 8, 16, 32, 64, here first term is 2, second term is 4, third term is 8 and so on. So here nth term is taken as 2 power n, which gives a geometric common ratio value. We note that in the example 1, 2, 3, 4, 5, etc. Here first term is 1, second term is 2, third term is 3 and fourth term is 4, etc. In general, nth term is n. So the common difference is 1. So this sequence having arithmetic common difference. The sequence with arithmetic common difference, we have to find the nth term of the sequence as an is equal to a1 plus n minus 1 into d. Here a1 is the first term of the sequence and n is the number of the term you are trying to determine. D is the common difference. An is the value of the term that are looking for. For example of a arithmetic sequence in the real world, suppose you are training to run a 6-mile race. You plan to start your training by running 2 miles a week and then you plan to add a half mile more every week. At what week will you be running 6 miles? The solution is, the first term of the sequence will be the initial number of miles you plan on running. The common difference of the sequence will be the half mile that you increase every week. N will stand for the number of weeks it will take you to reach 6 miles. So nth term formula is an is equal to a1 plus n minus 1 into d. Here an is equal to 6 and a1 is equal to 2 and d is the difference 1 by 2. We simplifying, we get the nth value. Next, let's move on to the sequences with geometric ratio. The geometric rule is an is equal to a1 into r power n minus 1. Here a1 is the first term of the sequence, an is the value of the term that are looking for, n is the number of the term you are trying to determine, r is the common ratio between terms. Example of a geometric sequence in the real world. Suppose you borrow $10,000 from a bank that charges 5% interest. You want to determine how much you will owe the bank over a period of 5 years. The first term in the sequences will be the initial amount of money borrowed, which is $10,000. The common ratio is 105%. This can be represented as 1.05 as a decimal. And n is the number of years you have the loan. So at the 5th year, we have to find the 5th term of the sequence. A5 is equal to $10,000 into 1.05 power 5 minus 1. The formula game. In the given example, we have to find the nth term of the sequence by using arithmetic common difference and geometric rule. The first example gives 1, 3, 5, 7, 9, etc. Here an is equal to 2n minus 1, which are having the common difference value 2. So we have to find the nth term by using the arithmetic common difference. And second example gives minus 1 plus 1 minus 1 plus 1, etc. Here the terms are in alternate from minus 1 and plus 1. So easily calculated the value of the nth term. An is equal to minus 1 power n. We are neither using arithmetic common rule and geometric common rule. Next, the third example gives 2, 5, 10, 17, 26. Here nth term is taken as n square plus 1. And fourth example gives 0.025, 0.25, 0.5, 0.75, 1, 1.25, etc. Here nth term is 0.25 into n. In the last example, 3, 9, 27, 81, 243. Here nth term is taken as 3 power n because first term is 3, second term is 9, third term is 27. So we are using the geometric rule. Next, we see the special type of sequence, triangular numbers. 1, 3, 6, 10, 15, 21, 28, 36 and so on. The triangular number sequence is generated from a pattern of dots which form a triangle. By adding another row of dots and counting all the dots, we can find the next number of the sequence. But it is easier to use this rule. Nth term is taken as n into n plus 1 by 2. So if you want to find the fifth triangular number, we just substitute n as 5. x5 is equal to 5 into 5 plus 1 divided by 2 is equal to 15. And the sixth term is 6 into 6 plus 1 by 2 is equal to 21. Next, we see the special example for a sequence, Fibonacci sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, 34 is a Fibonacci sequence. The next number is found by adding the two numbers before it together. The 2 is found by adding the previous two numbers 1 and 1, and the 21 is found by adding the previous two numbers 8 plus 8 and 13 and so on. So the rule is nth term is equal to sum of the previous two numbers n minus 1th term and n minus 2th term. So xn is equal to xn minus 1 plus xn minus 2. Here I can give the first 20 numbers of the sequence 0, 1, 1 etc. up to 6765.